Good morning, class. Today we're going to be learning about something that we deal with every single day. It's something that's inside of everything. It's something that's inside of us. Does anyone have any guesses as to what we're going to be talking about today? Yes, we're going to be talking about atoms and molecules. Now first, let's think of something that we know about atoms. Does anybody know anything about an atom? Anybody? Yes, it's inside of all matter. Great job. Does anybody know anything about molecules? Can anybody name a molecule? I'll be really impressed with that. I'll give you a hint. It's something that we should all be drinking 8 ounces of every single day. Good guess. That's water. Okay. So right now, we're going to start looking at a text called Atoms and Molecules, The Building Blocks of Matter by Louise and Richard Spilsbury. So with this book, we're going to start learning more about the atoms that we were just talking about, along with the molecules. So let's start with page 4. What are atoms? Everything that exists, from a glass of juice to a computer to a tree, is made up of matter. There are many different kinds of matter. Water, wood, and even your own flesh and bones are all types of matter. All matter is built from tiny pieces. These pieces are called atoms. When you build a model from plastic bricks, you can use a lot of small bricks to build bigger things. Atoms work together in the same way. Okay, so what did we just learn? We just learned about atoms, that they are pieces that they build matter. They're the tiny pieces of matter. So let's write that down. Alright. So now that we have that written down on our board, let's keep reading. Okay, so let's look at this guy right here. Like these model buildings, all matter is made up of building blocks called atoms. So all of these little tiny buildings are made up of smaller pieces, which resembles atoms. Did you know? Ancient atoms. People first guessed that matter was made of atoms around 2,500 years ago. An ancient Greek man named Democritus realized that you could cut matter into smaller pieces. Eventually, you would be left with pieces that could not be cut any smaller. Democritus called these tiny building blocks of matter atomos. This word means something that cannot be split up. So if we had an atom, do you think that we could split that atom up? No? Let's keep reading. Seeing atoms. Some things, such as a flake of skin, are too small to see clearly with our eyes. We can use microscopes to see many tiny things. However, atoms are far too small to see with an ordinary microscope. 4 million atoms could fit side by side on the head of a pin. Scientists use special sensors to find out how big atoms are. I don't know about you guys, but the question of whether or not you can break an atom into pieces is really sticking with me. I think we should write that on our board. Okay. So if we used a microscope that we have in our classroom, do you think we would be able to see an atom, or would we need a more special kind of microscope? You think we would need a more special kind of microscope? Let's keep reading. Different kinds of atom. Many different types of matter make up the universe. Scientists know of about 115 different kinds of atoms. Some types of matter are made up of just one kind of atom. These are called elements. For example, the element gold is made up of gold atoms. However, most matter is made up of many different types of atoms joined together. For example, plastic bricks are made up of carbon, hydrogen, and other types of atom. If we read this caption right here, some elements come mostly from deep inside the earth. They can be brought to the surface by a volcano. What is inside atoms? When something is really small or complicated, people sometimes make a model of it. The model makes it easier to look at and study the object. Scientists make some models of atoms to show what they are like inside. Atoms are tiny, but they are made up of even smaller pieces called particles. So did you guys know that atoms contain even smaller pieces? I think that's really interesting. Particle types. Most atoms are made up of 3 types of particle. The particles are called protons, neutrons, and electrons. The protons and neutrons are bigger than electrons. They are always clumped close together in the center of the atom. This clump of particles is called the nucleus. The nucleus is very small compared to the size of the whole atom. Most of the atom is empty space that contains 1 or more electrons. So let's look at this little diagram right here. Let's go ahead and draw that on our board so we can refer to it later. So here we go. So here we go. We'll label this as the nucleus. Okay. Now let's continue reading about electron paths. Electrons are the smallest type of particle. They weigh about 2,000 times less than protons or neutrons. Electrons move very quickly around the nucleus. They do not always travel in the same direction or path. You can imagine their paths forming a sort of shell around the nucleus. The electrons are attracted to protons, much like the way magnets are attracted to each other. This keeps the electrons near the nucleus. Alright, so now that we have our little diagram of an atom right here, let's throw some electrons in here. So we're going to draw a big circle around our little atom that we've drawn, and we're going to draw some other smaller circles on there. These are going to be our electrons. Alright, let's keep reading. Did you know? Fast electrons. In a hydrogen atom, the electron travels at a speed of 1,367 miles each second. At that speed, it could travel around the Earth in about 20 seconds. It would take a space shuttle well over an hour to complete the same trip. If a nucleus were as wide as a basketball, the atom it was part of would be very big. You could fit 8 blue whales nose to nose inside of it. Isn't that crazy? Okay. Alright, let's continue reading. Particles and mass. Mass is the amount of matter in an object or substance. An atom gets its mass from the protons and neutrons in the nucleus. The size of these particles is always the same, but their numbers are different in different elements. For example, a hydrogen atom has 1 electron, 1 proton, and no neutrons, while a lead atom has 82 protons, 82 electrons, and 125 neutrons. This means that a lead atom has a greater mass than a hydrogen atom. Particles and properties. Physical properties can be observed or measured without changing a substance into something else. An element's appearance, hardness, and melting temperature are all physical properties. Chemical properties describe how an element's atoms behave when described with other elements. For example, the physical properties of the element sodium, that it is soft and white. Its chemical properties include the ability to combine with air and water to make new substances. Okay. So we're going to skip past this case study in order to learn more about molecules. Some matter is made up of one type of atom. So what did we just read about earlier that was made up of one type of atom? Elements, that's right. For example, pure gold jewelry is made up of gold atoms. However, most matter is made up from groups of two or more atoms joined together. These groups are called molecules. So what do you think? Do you think your clothes are made out of molecules, or do you think they're an element? Good. They are made out of combinations of molecules. How do molecules form? The atoms and molecules are held together by forces that exist between them, like ropes pulling them towards each other. These connections are called bonds. So is that what you think keeps the molecules in your clothing holding together? Is it the bonds? Good job. The bonds in molecules are formed by electrons, what we just spoke about earlier around the atom. The bonds in molecules are formed by electrons. Some of the outermost electrons in an atom are held very loosely. They can move from one atom to another. Sometimes the atoms share electrons. The sharing or exchange creates a pulling force between different atoms. This pull is similar to the magnetic attraction between two magnets. Easy bonding. So before we continue on to the next section, what did we learn about molecules? We learned that they're held together by forces. All right. So whenever a force is holding together two atoms, what is that called? It's called a bond, correct. Okay, so let's continue reading. Some kinds of atom form molecules more easy than others. The ability to form bonds is a chemical property. It all depends on the number of electrons, protons, and neutrons an atom has. For example, a hydrogen atom has only a small pull on the electron, and this means that the electron is shared easily with other atoms. However, a gold atom does not bond easily with other atoms because there are more particles holding together in its nucleus, holding its electrons tightly. Okay, so we're going to pause with the book right there, and we'll continue with that with another lesson. But right now, we're going to make our own molecule based on what we have already learned. So, everybody should have 2 white gumdrops and 1 red gumdrop and 2 toothpicks. So what we are going to do is we're going to create a really common molecule that you guys were able to tell me at the beginning of class. We're going to create a water molecule. So what we need is 1 atom of oxygen, and we're going to use the toothpicks to represent the bonds of the electrons with each of the atoms. And it should look like this. And then we are going to take our hydrogen atoms and we're going to stick them on there. Just like this. So who can tell me what's happening? What do the toothpicks represent? Good job. The toothpicks represent the bonds in between the atoms. So now what do you guys want to do with your molecule? Do you want to eat it? Go for it. Good job, guys. Thank you for paying attention.